Hello and welcome. The IB Chemistry exam for May 2022. It's happening in just about 2 weeks from today, on the 18th of May. And if you're not taking sports science and you're not taking French, this will be the last of your IB exams. On the 18th of May, in the afternoon, SL students, you'll be sitting for your paper 1, 30 multiple choice questions, spanning topics 1 to 11. And there's no option, of course, this year, so it's just 1 to 11 that you'll study with no paper 3. Do a good job of studying those topics and focus particularly on topics 1, 4, 8, and 10. Then, SL students, you'll be moving into your paper 2, which is made up of 50 marks. It's 1 hour and 15 minutes long, and this paper will account for 50% of your final score in IB Chemistry. The multiple choice accounts for 30%, and the IA accounts for the remaining 20%. HL students, you will have much of the same, but of course, you will have to study additional work from topics 12 to 21. And as you HL students go into your preparation, it's really important that you focus on this HL section primarily, focusing on 13 to 21. And at this stage, it's most useful to focus on those topics and to back yourself that you could have sufficient overlap from this into the core areas as you focus your attention on this, which is by far the more important area to focus on, because it's definitely going to show up in the exam. It's what makes the difference between HL and SL, and then of course this is the more difficult content. You will have a paper 1 that consists of 40 multiple choice questions, and you'll have a paper 2 made up of 90 marks, 2 hours and 15 minutes. You also will have 50% of the weight for paper 2, 30% of the weight for paper 1, and 20% of the score from your IA. Now, last November, students took the IB exam, and I want to take this opportunity to go over 2 questions in particular that proved difficult for students. And then, of course, I want to bring your attention to all of my tips from previous years, last year, 2019, and all of the years before that. And of course, to my playlist of multiple choice questions, over 70 questions worked through on that playlist, and also my playlist for paper 2 problems that I've solved. All of those links are going to be in the caption below this video. But for now, let's move in and take a closer look at those 2 questions and a quick scroll through of the examiner's report from last November. Which combustion reaction releases the least energy per mole of C3H8? This, of course, C3H8 is an alkane, propane, and these are the bond enthalpies associated with the bonds on this side and the bonds on this side. All of these are combustion reactions. Combustion reactions are always exothermic, and it's the same hydrocarbon that's being combusted, but one of them here has incomplete combustion and this one has complete combustion. But you're given these bond enthalpies. Remember, in paper 1 you don't get a calculator and you don't get a data booklet. So with this being the only data given to you, then what you'll have to be looking for is to calculate all of the enthalpy changes associated with each one, and then looking for which one is least negative, because more negative means more exothermic. Negative delta H is an exothermic process, and the more negative the answer is, the more energy is released to the surroundings. So you'll be looking to solve this question and find the answer that has the least negative outcome when you take bonds broken minus bonds formed. Now, what you might be looking for is where are the bond strengths for C3H8 and where are the bond strengths for H2O. They are not given. You don't have a data booklet. So what you're expected to do is to observe and to see that all four answers have the same reactant on this side. So all of the bond breaking that's happening on that side, that's going to be requiring energy, is going to be the same. So you can cancel those out. And all of the bond forming on this side with H2O, 4H2O, another 4, another 4, and another 4. All of those can be cancelled. So therefore, what you're looking to work with for your bonds broken minus bonds formed are the oxygens, the carbon dioxides, and the carbon monoxides. And yes, you don't have a calculator, but notice that all of these numbers are in the hundreds. So you are expected to do some mental math and to do the bonds broken minus bonds formed. So let's start with 5 oxygens. 5 oxygen to oxygen bonds have to be broken on that side. 5 multiplied by 500, 2,500. 4.5 multiplied by 500, 2,250. Here, 2,000. And here, 1,750. So that is for all the bonds broken on this side, not considering these because all of these answers will be the same. Then on the bond forming side now, and you have to be careful and remember that CO has this structure. So every one molecule of carbon dioxide has 2 carbon to oxygen double bonds. So therefore, for this first one here, 3 CO2s, you're going to take this and multiply it by 6. That's going to give you 4,800. And this minus this would give you negative delta H of minus 2,300. Here you have 2 CO2s. That would be 4 multiplied by 800, 3,200. And 1 CO, that will be 1,000. This 2,250 minus 4,200 would give you 1,950. Negative 1,950. So you realize that complete combustion is more exothermic than this combustion here, which is not quite complete because it has carbon monoxide. But going down to get all of the answers, we'll see that 1 CO2 here, that is going to be 2 multiplied by 800, 1,600. And 2 COs, that will be 2,000. 3,600, this would come to negative 1,600. And finally, this is 3 multiplied by 1,000, 3,000, negative 1,250. So the answer for this question, the least energy per mole would be released here. This is the least energy release, the smallest number with the negative sign in front of it. Exothermic processes release energy to the surroundings. The more negative the answer, the more energy released to the surroundings. But more importantly, what you have here is some knowledge that tells you for the complete combustion, the enthalpy change or the heat energy released is minus 2,300. And for the incomplete combustion, minus 1,250. And for 2 combustions that are in between, you have a trend going from negative 1,250 to negative 2,300. And it's for all of these layers of reasons that students found this question to be particularly difficult. And that, of course, highlights why it's so important for students to go beyond their textbook and a few questions in their books, and to take the time to practice with past exam questions. Answer for this question is D. Good luck to everyone in this year's examinations.